going to be talking about Firestore today. My name is Natalie Vais, and I'm a product manager on Cloud Firestore. I will be joined by my colleague, Ben Whitehead, who's on our developer relations team, and he will come on stage later on in the presentation. So first, I wanted to start with a quick overview of the session. So the main goal of this session is for you to walk away understanding what Firestore is, what it's good for, and how you can integrate it with other parts of the GCP ecosystem. For those of you who are new to the product, I'm going to start with an introduction and a history of the product. I'll highlight some of the new product announcements that we made this year as part of going generally available in January. I'll walk through some of our example customer architectures of people that are using this in production today. And then finally, I'll give it over to Ben, who will walk you through a demo demonstrating Firestore in action. We'll also leave some time at the end of the session for Q&A. And speaking of Q&A, how we're actually going to do it in this session today is using an application called Dory, which we use internally at Google to manage Q&A at scale. You can actually find this through your next mobile application for this session. This will allow you to submit questions throughout the period of this session, and you can upvote and downvote other people's, and I'll be using that to moderate at the end of the session. So please feel free to check that out. So let's go ahead and dive into an introduction to Firestore. Before we jump into that, I'd like to get a bit of a sense of the audience we have today. How many of you out there have actually used Firestore already? That's awesome. Looks like 40%. How about the real-time database, Firebase real-time database? OK, less of you. And how about Cloud Datastore? Cool. Sounds good. That's good background for this session. So Cloud Firestore is one of many database offerings that we have within Google's cloud portfolio. Here, you can see a list of all of the managed database services. Cloud Firestore is our NoSQL document-oriented database, making it part of our non-relational offering. And we'll talk about this data model a little bit later in the presentation. I want to take a step back briefly and imagine that you're trying to build a mobile app for your company. If you're starting a project from scratch and you want to build it yourself, you're likely going to have to think about a couple of things. Number one, setting up a database, which you'll probably have to run and scale yourself if you're taking something off the shelf. In front of that, you'll need to put some sort of API layer that can make queries from your clients. That probably means also adding an authentication layer so that you can make sure that users that are accessing your data are authenticated. And this also means adding some sort of sync logic so that you can make sure your data is syncing with the local results. And finally, these local results are probably going to be stored in a completely separate client database that, again, you have to make sure is syncing with your database that we mentioned up at the front. Now, when you arrive here, all of a sudden you have a pretty complex set of solutions. Each of these, as a standalone, could actually be a whole company in itself. And that's what we actually see today, is that people are having to go to many vendors, many different places to actually accomplish this stack to build their mobile or web app. And this is why we built Firestore. Firestore was built to tackle these problems that are very common to mobile and web app development and to simplify this process for you. For those that are familiar with Cloud Datastore and the Firebase real-time database, an important question is, how does this relate to those? Cloud Firestore is the next generation of Cloud Datastore. And it includes important learnings from the Firebase real-time database. So we took a look at the developer wish lists from each of these, and we used those to inform the decisions that we made when building Cloud Firestore. So you can think of this as the best of both worlds. It takes some of the best elements of Datastore and some of the best elements and learnings from Firebase real-time database. The first thing to know is that Firestore is fully supported in the Firebase SDKs. This includes web, iOS, and Android. So you can access data directly from the clients. This is actually pretty unusual for a database, and it's not lost on us that letting clients talk directly to your database can pose all sorts of challenges. For one, you can't always trust the data that's coming from clients. And secondly, you're dealing with potentially unauthorized users. So This is where Firebase auth and security rules come in handy. These allow you to validate operations from the client, and this removes the need to build that middle tier that you saw on the previous slide, which can sometimes be its own standalone server just to manage authentication. Now, the next thing that's very important is the ability to have these applications work across multiple devices when we're talking about client access. Maybe you put down your phone, you walk over to your desktop computer, and you expect to resume the same state in your app that you're operating on. So this is something that Firestore handles natively, and it makes it really, really great for those applications that you want to develop and serve to multiple types of devices at one time. Now, another problem that's very, very common these days is people expect their apps to work offline. It's fairly normal for people to look at their mobile applications when there's little to no chance of connectivity. Maybe you're running through the airport, you're at the top of a mountain, or maybe you've gone offline on purpose. So the same technology that allows us to operate in offline mode also helps in those situations where we have spotty network connection. And so, as you can imagine, this is very challenging to solve, and we've actually built this natively into Firestore. It requires building complex sync and conflict resolution logic on the client. So in Cloud Firestore, our client libraries come fully equipped to handle these use cases. So let's talk about the data model in Firestore. We mentioned already that Firestore is a document store. So at the smallest unit of storage in Firestore is a document. And a document, as you can see up here on the screen, is a lightweight record that contains key value pairs. There is no schema enforcement in Firestore, so you have complete freedom over what fields you put in a document. Now, documents can be grouped together in related groups that we call collections. And you can see that representation up here. Documents can also map to sub-collections, and this lends itself really nicely to hierarchical data that's very common in web and mobile app development. So what we've seen so far is that this model works really, really well for developers and is designed really well to scale as well. So let's talk about what's new in Cloud Firestore. As I mentioned, Cloud Firestore went generally available just earlier this year at the end of January. It was in beta for a little over a year before that, since 2017. So as part of the announcement of going generally available, we have some pretty cool new things that we've announced. So the first thing I want to mention is that Cloud Firestore operates in two different modes, Datastore Mode and Native Mode. These have slightly different strengths that I will highlight based on the use case that you're looking for. So the first thing is that Datastore Mode has the exact same API and same scale as Datastore, but a new storage layer. So if you are a Datastore customer, this one will feel very familiar to you. And in fact, eventually, all existing Datastore customers will be able to upgrade to Firestore and Datastore Mode. Datastore Mode also has some new things that are greater than some of the things offered in Datastore today. And those things include strong consistency, where we had eventually consistent queries before in Datastore. We also have a higher availability SLA, which I'll talk about in a second. And we also have a new Dataflow connector. So on the other side of things, we have native mode. And native mode leverages this new document model, and it integrates with third-party clients, and that's kind of the main difference. And for those of you coming from the Firebase real-time database world, it's more akin to the model there with the direct client access. A simple way to think about this is that Datastore Mode is optimized and scales really, really well for your writes, and native mode scales really, really well for concurrent connections. So when you're thinking about all these different clients trying to connect to the same application at once. As part of going generally available, we also announced 10 new regions, 10 new locations that are a combination of multi-region and regional. So you can see we have two new multi-regional locations that are highlighted in green. We have one in the US and one in Europe. And these multi-region locations can actually withstand the loss of entire regions because they're replicated across more than one. And this maintains availability without losing data. And all of these regions are actually required to be at least 100 miles apart. In addition, we have new service level agreements that are attached to each of these different types of locations. So the first, for multi-region, which is our highest SLA, we have 5 nines availability. And for regional, we have 4 nines SLA. Both of these are actually improvements over the SLAs that you saw in Datastore, which were 4 nines and 3 nines respectively. And lastly, you can access Firestore directly from the Cloud console. Many of you who come from the real-time database world may know that you can also access Firestore from the Firebase console, and that's very common as well. One of the things to note about these UIs is that they both operate on the same projects. So if you create a project in the Cloud console, it's the same project that you'll see available in the Firebase console as well. One of the benefits of using the Google Cloud console is that you have access to all the other GCP products that I mentioned, including things like BigQuery. And that's something that we're actually going to showcase later in the demo, is how to get some of the data that's in Firestore into BigQuery. So let's walk through a couple of customer examples. Since we went GA, we've seen a huge diversity of workloads since launch, and some of these were actually some of our early beta customers as well, back from 2017. So we have a lot of customers that span tons of different industries, but they do have a couple of things in common. The first is that a lot of these companies needed a really quick time to market. So they didn't want to spend all this time, provisioning servers, picking things off the shelf, and stacking things together. Second is that they needed something that would have the ability to scale with their business. They wanted the same solution for their 10 users that they want for their 100,000, 1 million user use case. And the third thing is that a lot of these companies had really lean development teams. And they wanted to operate in a serverless environment. And as we know, Firestore is a serverless environment. You don't have to think in terms of nodes that you're provisioning or capacity and resource planning. In fact, the pricing is actually built on an operational model based on the reads and writes that you're actually doing against the system. And this is huge because Firestore does not require a massive team to run it. And that's the beauty of it. The same team that gets you started can actually carry you through the scaling of your application. The first one of these customers that I want to highlight is a company called Hawkin Dynamics. They build sophisticated hardware and software for athletic monitoring that's used by several professional sports teams. So this hardware that they develop includes what you can see up here on the screen, which is wireless force plates. And these wireless force plates measure the impact and movement of athletes, and they can track and measure the performance of these athletes over time by capturing this isometric data in their application and sending it back to Firestore. Here's what their architecture looks like. They have the wireless force plates, which capture and send the data to the Hawkin Dynamics mobile app. This collects information across athletes in many locations. And because their testing facilities are often in low connectivity areas, as you can imagine, fields, maybe they're doing something at high altitude, the ability to have this offline sync is very, very important to them. So they can do their tests, capture the data for the athletes, have it sent back to the application, and then they have coaches or other people that are monitoring the athletic statistics connecting from other devices like tablets and desktop computers that can access this information immediately. So this is very important to them. And they've actually been kind enough to share their data model, so we can drill into a little bit of how they've actually modeled their business using the Cloud Firestore document model. So what you'll see up here is a top-level collection called Teams. Each of these, this collection contains documents, one of each corresponding to each of their teams. And these teams have sub-collections. And these sub-collections, you can see some of them listed here. It can include settings, raw force data that's collected from the force plates, different tests. If we drill in a level further, they also have a sub-collection called athletes. So here there's a document for every one of the athletes that they're collecting this information on. And here they can drill into all of the tests that have been captured or performed for that athlete over time. The next customer that I want to highlight is one that you actually may be familiar with. There's a high chance that you went to this website because you're all here today, or that you accessed the mobile app. So our developer friends over at The Nerdery, I think we have some of them potentially in the audience there. So they are a digital consultancy that actually helped build the conference web and mobile apps for us using Cloud Firestore. So they use Firestore as an aggregation hub for all of the conference data that's serving the session information, the breakouts, etc. And again, we actually have a data model to show you and see how this works. So here you can see an actual document that represents content that's being served to the next homepage. And in this case, it's the mobile app homepage. So you can see the content being served here. It also has static content that's being stored elsewhere, and you can see the path to that information here. If I click to the next, this is actually a high-level collection representing all of the different next events. So the one that's highlighted right now is the one that you're in here today for, which is Next SF. You'll also see entries here for the future next events that we have in Tokyo and London. And here is actually the session we're in right now. So this document represents the session ID. You can see here we have information about the session type, the different related fields. So these are sessions it recommends you go to if you also have gone to this one. And then speaker IDs, which refer to both Ben and myself. Something that's not on the screen that also exists in the app is a field lower down that tells the capacity of each of the sessions. So you can imagine if the capacity is full, it will no longer let someone register for that. So when you first visit the conference site, what you're seeing is a session and speaker information that's being loaded from Firestore, as well as some of the static images and assets from Google Cloud Storage. When you sign in with either your Google account or personal email address, you're actually hitting Firebase Auth, which is authenticating you and making sure you have the proper account and you have access to all the information you're seeing. Then when you register for a session, like this one that you're in today, the app makes an API call out. It updates the information in Firestore and immediately updates that information to the user. So next, what I want to do is invite Ben on stage. Now that you've seen some customer examples, I want him to actually demonstrate Firestore for you in action.
Thank you, Natalie. I am Ben Whitehead. I'm a developer programs engineer with Google Cloud, focusing on Cloud Firestore and Cloud Datastore. So I'm going to be running through a demo today showing how we've got a demo app built leveraging the real-time functionality of Cloud Firestore, as well as some of the larger suite of GCP to handle doing analytics tasks to kind of help the business understand how your app is behaving. So first, we're going to look at a couple of architecture diagrams just to give a high-level view, and then we'll dig into some of the details. So here we've got a high-level architecture diagram of the app that we're going to be demoing and analyzing today called FirePixels. In the little mobile icon, you can kind of see that there are 4 colored quadrants. This is actually the Firestore logo colored using the Google colors. So each of these respective quadrants is made up of 10,000 pixels, and each of those 10,000 pixels are backed by a document in Firestore. So in Firestore, we actually have a document for every single pixel that's maintaining the color of that pixel, the last updated timestamp, as well as a partition that we're using to parallelize the events propagating to the UI that we'll be able to see in the real-time demo in just a few minutes. So given that there are the 4 quadrants, each of them have 10,000, this can handle up to 40,000 concurrent users, essentially kind of poking at the bits to represent each of the pixels. So we've got a simulation service running on GKE that's actually running a simulation of some user activity. So you will be seeing pixels kind of updating when we get over to the demo. So we've got this application up and running. We've gained a fair amount of user traction, and the business comes over to us and says, great, you've got this thing. We need to start getting some numbers. And because you were very quick to market, that probably didn't mean that you baked all of your analytics into your app from the get-go. So how do you kind of reinforce and get information for your users? So the particular business questions that we're going to be answering today are, what are the number of distinct color events that have happened over the past 30 minutes, over the past 2 days, and over the past 7 days? The next question is, what are the number of distinct colors that occurred in the last minute for the past 30 minutes? And finally, we're going to have a chart that we are going to use to monitor the ingestion latency of how long it's actually taking to process these events from user actions to it being available in the data warehouse. So this is a high-level architecture diagram, essentially expanding on what components we're going to be looking at today. So on the left-hand side, the yellow box, that's a little faint, sorry about that. The left-hand box represents the same slide that we just saw previously. So we can see here Cloud Firestore is sort of the bridging point into the rest of GCP that we're going to be integrating with today. And we're going to specifically be using Cloud Functions to monitor change events on each of the pixel documents inside the database. When each of those events is triggered, we're going to handle that event, process it, and feed that into BigQuery that will then be used to generate some predefined views to feed charts inside Data Studio so that we can put up a dashboard in our office for everybody to be able to look at. And since Cloud Functions are these kind of magic ephemeral things, we need to have some monitoring for us. So we're going to leverage Stackdriver to do essentially metrics monitoring and invocations per second and those sorts of things over time. Can we switch to the demo laptop, please? OK, great. Over here on the left-hand side, this is the FirePixels app. This is a real-time app. This is running, hitting Firestore. We can see each of the 4 colored quadrants currently have colors. Oh, look, cool. Our simulation just kicked in. That bottom left quadrant was updated. And we've got a number of document listeners on the back end that are listening for those simulation events. So that was just 10,000 writes to the database and the events being triggered, audited, sent to the back end, as well as aggregated, and then sent down to the web client over WebSockets. So it's very responsive. It can give you a great experience for your users. And we'll be able to kind of see that changing over time during the rest of the presentation. So first, we're going to jump over to Cloud Firestore in the Google console, and we're going to take a look into the data model that's actually backing the FirePixels app right now on the left-hand side. So here on the left-hand column, we've got 3 different collections, top-level collections, one for devices, one for input, and one for pixels. The collection for devices, this is actually a heartbeat collection. So for each of the respective clients that are managing each of those pixels as part of the simulation, we're essentially tracking the heartbeat of the last time one of those users actually did something for us. If we move down to the inputs collection, we can see a 0 through 3. The 0 through 3 here represent each of the colored quadrants over on the left-hand side, starting top to bottom, left to right. Excuse me, left to right, top to bottom, so 0, 1, 2, 3. In each of those documents, we can see the color. We can also see the updated timestamp of the last time that quadrant was updated. And if we look at the pixels collection, here we can see a list of the 40,000 documents that represent each of the pixels. So the name of the document that we've got here is essentially 3 digits dash 3 digits. This is representing the XY coordinate in the grid. And we can see the color for that particular pixel, which partition that pixel is associated with, and the last updated timestamp. So while the simulation is running, wow, we got it all blue. That's really unusual. Let's take the top right, and let's change this to be yellow. So I can hit that. That's going to trigger the events. All of the event handlers on the back side are going to observe that particular part of the simulation. They're then going to update each of their respective pixel documents. And then, again, that's going to be aggregated to the back end and sent over to the UI. So you can kind of see like how quick and responsive that is, even from like an administrative standpoint. From there, let's jump back over to the Google Cloud Console. Quick overview here. The Google Cloud Console is trying to help you out and kind of surface information that's relevant to you based on how your project is behaving. So for our project, we are using a compute engine to run our GKE cluster for our simulations. We've got some GCS buckets, Google Cloud Storage buckets for storing some static assets. We can also see that we're using cloud functions. We currently have one function that's deployed. And we've got one data set in BigQuery, which is ultimately the data warehouse data set that we're going to be working with today. And we can also see a quick overview of the number of API requests, as well as compute engine CPU processing. The API requests, this is aggregated across all of the various backend products in GCP. So this can give you kind of like a good idea of how much of GCP you're using without necessarily having to build up a big graph all by yourself. So for here, let's start from Cloud Functions. So I'm going to open that up in a new tab real quick. This is the single cloud function that we have active right now. If you had more cloud functions, they would show up in this list. You get a quick overview what region the function is running in. This is important for data locality, just in terms of latency of processing. It's also becoming increasingly more important due to regulatory restrictions around data egress and migrations and those sorts of things. The trigger type of the function. So there are many types of triggers that you can use with Cloud Functions. Today we're using Cloud Firestore. You could also use it with Google Cloud Storage when a new document is created, or other sorts of things like that. For this example, we're using Node.js version 8. This is convenient, gives us the async await handles, so it makes our code a little bit more terse, which is nice. I've given this function blindly 256 megabytes of RAM. I seriously doubt I'm using that much, so I should probably knock it down to save on some billing, but I haven't been harassed about that yet, so we'll worry about it later. And then the function inside our code that's going to be called as part of the event handler is called onPixelChange, and we can see the last time that this code was deployed. So we'll just click in here and load up some of the details. When we click into each of the functions, we get a high-level overview showing the number of invocations per second, where we can kind of see success, failure, error rates, those sorts of things. Just in a high-level view, this little peak that we notice on the right-hand side, this is when I manually changed the value in the database a couple of minutes ago, and those events got kind of processed immediately. So that's higher than the normal simulation is normally doing. You can see that you can kind of get some different time granularities, but ultimately, this information is sort of bounded to what time boundaries you have here. So for longer-term storage and monitoring and alerting, we'll leverage Stackdriver for that, and we'll get to that in just a minute. So scrolling down a little bit, one thing that's not shown on the summary page is the service account down here. The service account is actually very important. So the service account gives your function an identity as far as access controls and security are concerned in the greater GCP. So when I'm integrating with BigQuery, the identity of Next.io storage service account is given the permission to write into BigQuery. So if you've got many projects or many teams, you can do fine-grained controls to where you could say, like, this function is able to write to this thing in BigQuery, but this other function is only able to interact with GCS. So it gives you that kind of control to be able to handle multiple things at the same time. So jumping over here to the trigger. We saw the trigger type earlier as Cloud Firestore. The particular event type that we're caring about right now is update. There is also the create and delete, as well as just general write. So this can be really nice from like an auditing standpoint or doing data ingestion for analytics, as we're doing today. Without having to do modifications to your database or to your app, you can essentially hook up monitoring, those sorts of things. And then the resource path right here. So if you remember, back here in Firestore, we've got our pixels collection. If you think of this as sort of like a directory structure that matches with the document collection, sub-collection, document sort of pattern, right now, essentially I'm specifying like a directory structure that says underneath the patterns or the pixels collection, I want to match on any pixel. So inside curly braces is essentially like a variable placeholder. So over here on the source tab, I'll pull this up for folks. So this massive 30 lines of code is the sum total of code that you need to be able to get an event from the Cloud function into BigQuery. So the BigQuery node module, we're able to just import up here, the data set that we're inserting to, the table that we're inserting to, and we're creating the BigQuery client right here on line 5. You'll notice there's no credential passing or, hey, load up this thing or anything like that. The default constructor for the clients is defaulted to using the service account. So if you're running something on Cloud Functions or you're running something on App Engine or GCP, the environment is essentially bootstrapped for you already to use the service account information that you've configured through the Cloud API. So moving down a little bit, lines 7 through 26 are the full function. At line 8 and 9, we're essentially pulling out the time 0 values, and then on line 9, we're pulling out the time 1 values. And then we're constructing our data structure that we want to send to BigQuery. So that's the pixel that's being modified, essentially the pre and post values, as well as the process time when this is actually being processed and sent it to BigQuery. Then on line 21 is where we're doing the actual write to BigQuery, and our function is effectively done. We do have a console log statement here. I should have cleaned this up. It's not actually doing anything useful for us at this point. But the logs that I write to the console here are actually available in Stackdriver. So if you're setting up your function and you're like, hey, did I actually get the data there? Or I'm kind of curious what the events look like, that sort of stuff, you can do your kind of printf console log inspection, and all that information shows up in Stackdriver. OK, so jumping back to the Cloud console real quick. From here, pardon me, I actually skipped Stackdriver. So let's pull up Stackdriver first. So Stackdriver, if folks aren't familiar, is the kind of monitoring, user-side monitoring hub for your apps and usage of GCP on GCP. So here we can see essentially a metric graph. It looks very similar to the overview, the overview that we had back on the function page, but it does give you the ability to do broader time spans, so we can actually look back and see the development work that picked up in the middle of May for this particular demo. You can even do custom timeframes if you wanted to, as well as real-time dashboards if this is something that you want to kind of put in your team's bullpen or something like that. So let's jump back down to an hour. So right now we've got 3 different charts. So we're tracking the number of executions of our Cloud function per second. In the case of Stackdriver, this is being aggregated up to per minute buckets. So we can see over time, again, that little peak when I manually change the database. Scrolling down, we can see the Cloud function instance count. So this is one of the things that's really powerful about Cloud functions, is essentially it takes care of all of the scaling factors for you. So by us triggering events and events being in-queued to be processed, GCP figures out how many functions it needs to scale up for you and when they can be able to scale down and back up and those sorts of things. So that's why you're seeing some kind of like spikiness, is when it's scaling down, it's trying to save me money. When it's scaling back up, I'm giving it more work to do. The final chart down at the bottom is a pretty cool little chart that Stackdriver provides, which gives you a heat map. So instead of having to look at your like 7 lines for your P50 and P95 and all that stuff, it'll actually just render a heat graph for you. So we can see here that most of our events are processing in about 100 milliseconds. This little hotspot down here, when I did the manual trigger again. But this is nice because you can kind of start to see things over time. If we were to expand this to the last week, we can see that it's been running relatively consistent. We've had a couple high latency pokes at a couple different point in times. But nothing super concerning as they've kind of come back down. It looks like our peaks are about 5 seconds or so. So jumping back to the Cloud console, from here we're going to jump into BigQuery and take a look at the data set. OK, so hide the editor. So this is the schema of the pixel tables. You notice it looks exactly like the JSON document that we looked at in the function. Unlike Firestore, BigQuery is schema'd. but this is to help out with query planning and just kind of the dynamic nature and analytics and the fact that it's SQL oriented. So if we click on preview, we can actually see a summary of some of the data that's in there. So for pixel 66, 103, we changed from red to blue. Partition stayed the same, and then we've got the respective timestamps. This all supports kind of your standard SQL that you're familiar with. So I could do like select star from the Cloud Console. Also has nice auto-completion for you, which is really great, because inevitably you end up getting kind of long names and historical names and all that stuff. Let's see. Order by T1 updated, descending, limit 10. And we can hit go. And it'll essentially just start crunching. So in our full database, so far we've got something like 600 million events that have been stuck in our data warehouse, and that's in the span of about 2 weeks. So as apps get more sort of IoT and user intensive, you can imagine like just having a database that can scale out and give you quick queries is really valuable, and that's what we're getting from BigQuery. So we're going to jump down here and look at a view real quick. So the views that we've got defined here are essentially what we're using to drive the charts that I'll show you in just a second. You can see that they're kind of standard SQL, select from, table, group by, ordering, limits, all that same normal stuff. So you're not having to learn a brand new like charting library or anything like that. You can just write your SQL statements and then load that up in your dashboard. So we'll jump over here to the FirePixels dashboard. So this is a dashboard that I've created in Data Studio. One of the things that's really nice about Data Studio dashboards is it fully integrates with all of your G Suite organization structure. So this dashboard that I'm showing you right now is actually shared to my demo user from my main work user. So this is really nice if you need to like put it on a display in your bullpen, or if you only want to share it with maybe your manager before it's published to the rest of the company. You've got full ACL control the same way that you do with Google Docs. So here on the top row, we can see 3 different charts with color breakdowns. So these color breakdowns are answering the questions that we mentioned kind of at the beginning of the demo around the business questions. So the business question is essentially how many, or excuse me, for the top row is what is the ratio of a particular color per time bucket over a period of time. So here we're seeing for the last 30 minutes, about 63% of the color changes were to blue, and the other 37 or so were to yellow. So this makes it really easy to kind of look at the chart, and having some context around the way that the app behaves, you can just kind of look at it and get an idea of what the app probably looked like at that point in time. And then that expands to 2 days ago as well as over the past week. In the bottom left, we've got our line chart that's showing the number of distinct colors that were changed to in that time frame. So here we can see that we had 2 that we changed to. One time we only had 1. One time we actually got all the way up to 3. Just various interesting things. And then the center chart is showing our ingestion latency. So this is essentially showing in seconds how long it's taking from the document being written into Firestore for us to write it into BigQuery. So this is essentially showing us an end-to-end latency of getting data into our data warehouse. So the vast majority are being handled in less than 2 seconds, and we've got a little bit of a kind of plateau here. This is actually, I believe, due to the fact that the cloud functions are spinning back up after being spun down between stages of the simulation running. And then there's almost a full drop-off by the time we reach 7 seconds. So the vast, vast majority of all of our events are being put into our data warehouse in 8 seconds or so.